Everyone, this is Abdulrahman Abu Hadid. I will illustrate the level of information need based on BSEN 17412, Level of Information Need Part 1 Concepts and Principles. So, what we need to specify when we talk about the level of information that we really need. So, we need to specify the geometrical information, the alphanumerical information, and the documentation. In terms of the geometrical information, there are 5 things to specify. First, the detail, dimensionality, location, appearance, and parametric behavior. In regards of the alphanumerical information, the identification and the information content should be specified. Let's start with the detail. The detail could start from simple till detailed. As an example, solar PV panels could be very simple or more simpler for the facility management purpose and could be very detailed for the visualization purpose. Second example, the RC column could be simple at the design stage and could be detailed for the construction stage. The door could be simple for the lead consultant at the early stage to perform the energy analysis, and the same door could be detailed for the visualization purpose. So this is the first one that we want to specify. The dimensionality could be 0D as a point, 1D as line, 2D as surface, or 3D. As an example for 0D could be the RC column at early stage as we want to perform the structural analysis. Another example is the road signage could be point at the planning stage as well. 1D could be pipes for the quantity takeoff. 2D surface. Let me ask you a question. For this model, Revit model by Autodesk, for the PV panels, these PV panels, could we need it as 3D really, or 2D surfaces enough for the planning stage? I think the answer is no. 3D. 3D example, of course, MEP services for the coordination purpose, concrete structure, most of our models are 3D. In terms of the location we need to specify the position of the element and the orientation. The position or the location, it could be absolute reference to reference point or relative reference to another object. Absolute, we have an example of ground-mounted solar PV panels, boundary walls. Examples of relative could be roof-mounted PV panels, windows, doors, a lot of elements, of course. The four things that we should consider: the appearance. The appearance could be symbolic, monocolor, or even not required. And it could be realistic, colors plus textures. As an example, RC columns, ducts, pipes, mechanical equipment, all of these elements, we need it as monocolor. No need for realistic color or texture. For the coordination purpose, for the 4D purpose, for the clash detection, for the engineering analysis. For the realistic appearance, it could be doors, windows. For the visualization purpose, augmented reality walkthrough. For the architecture elements in general, by the way. Last thing we will talk about is the parametric behavior. For the parametric behavior, it could be explicit geometry, constructive geometry, and parametric geometry. Explicit geometry. Explicit geometry means definition of shape as boundary representation don't allow for shape modification. For example, the model in place in Revit. For the constructive geometry, it allows for the shape modification, like doors, windows, columns. If we could specify the width and the height, we could change it, and the door will be changed automatically. Parametric geometry will allow for changes by equations. So in that example, beam with ledges shows an example of that. We could derive different geometries based on the equations and visibility checks. Second thing we need to specify is the alphanumerical information. First thing is identification. So we need to identify the element in terms of the name of the element, for example, windows, louvers, type name, 400 by 600, classification, codification, as per Uniformat 2, Uniformat 2010, OmniClass, or we could use index numbering. So we need to specify or we need to identify the element. The information content. We need to specify the information content in terms of the purpose milestones. We will talk about that after 1 minute. So for this column, for example, we need the information of concrete grade, keynote, specs, cost, waterproofing, reinforcement rate, dimensions. For this CCTV camera, we need the technical specs, cost, manufacturer name, service life duration. So each element is different than other element. Final part is the documentation. For this column, we could specify the specification, the schedule, the BOQ as an attached documentation for the column. For the CCTV camera, we could specify the O&M manuals as a document. Another examples of documents, reports like soil report, design calculations, schedules, BOQ, method statement, site survey, photos for progress and as-built, sketches, test certificates. As a summary, geometrical information, detail could be from simple to detailed, dimensions from 0D to 3D, location could be absolute or relative, appearance monocolor or realistic, parametric behavior explicit, constructive, parametric, identification by name, type name, classification, index numbering, and information content. For the documentation could be reports, manuals, photos, etc. There are 4 things to consider when we specify the level of information need. First thing is the purpose. What is the purpose of the information? So PV for facility management could be simple, but PV for visualization purpose could be detailed. RC column for clash detection purpose could be simple, but RC column for quantity takeoff could be detailed. Second thing to consider is the milestone. So RC column at design stage is totally different from RC column at construction stage in terms of the information need. Third thing is the actor, who is requiring the information. So for example, lead consultant needs to perform the energy analysis at early stage. We have 2 examples here. The left one is detailed, the right one is simple. So, and the left one has a lot of information, R value, solar heat gain coefficient, transmittance, cost, manufacturer name, and the other one has only the specific information that the lead consultant needs. So in terms of that, he will need this one. Last thing to consider, and in my opinion, this is the most important thing, is the breakdown. In BSI, in this standard, the breakdown could be according to the classification system, the system engineering, and federation strategy. The classification system, we all use it in the LOD matrix by BIM forum. This is the most famous one. But the issue in that LOD that it's a little bit complicated because it has a lot of information at each stage. So we could make it simple by this standard, according to this standard, and this is a trick part. We could make it bundle. All of the concrete elements at final design stage, for example, could be detailed or simple plus description, and this one is very important because this is the key point here. The description, dimension 3D, location is relative, appearance not required at all, parametric behavior is constructive. The information content in all of the concrete elements at final design stage could be name, type name, assembly code, concrete grade, keynote, cost, waterproofing, reinforcement rate, and the documentation needed, specification, BOQ, schedules. So this is just an example of how to think about it. Another example could be the MAP services at final design stage. So you could bundle it in terms of detail, dimension, location, of course, information content, documentation, and it might need additional breakdown in terms of maintainable assets and non-maintainable assets. So for example, the maintainable assets will need extra information for the facility management stage and will need O&M manuals as a document. And of course, we can't bundle the MEP services all together, but this is just the idea of bundling things together. We could consider it. Let's go to the implementation. Here is an example in the BS standard. which is Annex B. This example shows how to make the implementation of it. It's just an example, and of course, maybe in part two it will be more it has more description. So, for example, it starts with the information delivery milestone. Here, preliminary design. In my opinion, this is the key point for LOD 100, LOD 200, LOD 300. So this preliminary design could represent somehow the LOD 200. The final design will represent somehow the LOD 300. So no need to use these terms anymore, but instead we could specify it by the milestone itself. The purpose, visualization, cost estimation, fire and smoke simulation, and here the objects, sorry, here is the objects what we need from each object, side geometrical information, alphanumerical information. But again, I think this will be very complicated, and I believe that we could bundle them together as I have mentioned before. So it will be like a mix between the LOD table and some bundles of the information. I have finished, and I hope you understand the point, and I hope you understand my illustration. And thank you very much. This is done by Abdulrahman Abu Hadid.